Yo, what's good, guys? So today we're going to be going over this integral, um, integral of x log x squared, from 1 to e. So this is from the MIT Integration Bee from the year 2015. It's question 6 out of 20, so it's not too tough. It's about middle of the road. Um, so yeah, let's get started. So because you have a log or a logarithmic expression and an algebraic, and they're being multiplied, you're gonna want to use integration by parts. Um, so yeah, so this LIAT is the acronym for finding u, what your u should be. So since this is logarithmic and the other one is algebraic, since L is before A, we know that our u has to be our log expression. So this basically means that it's like its order of importance. Um, so yeah, so u is ln. I'm just gonna write this entire problem in terms of ln because you can ln and log in integration and differentiation are always interchangeable. If you do your answer in terms of one though, use it. You shouldn't just like halfway through decide to just start using ln's. You should always either when you start your problem just write it in terms of whatever you're gonna use it for the rest of the problem. So, um, if you don't know this, you can just straight up calculate it. It's just chain rule. It's just like one facet. It's just one order of chain rule. So 2 ln x times derivative of ln x is 1 over x. So our derivative is 2 ln x over x. Okay. So our dv has to be our x because everything else is already this is everything else. And then the integral of x is 1/2 x squared. Okay. So using the using the um you know the formula for chain rule, or not chain rule, integration by parts, it's this. Sometimes like teachers will write this in terms of f prime and g prime, but in terms of f of x and g of x, I prefer it this way just because I think it's easier to see. Because it doesn't look like a jumbled mess, whereas f and g prime I think do. So yeah, I think that that's more prevalent like overseas. They'll write it in terms of f prime and g prime, but in the states we don't really do that. So uv, I'm just gonna actually write this with my x squared first. Okay, and then integral of v du. V this is a u. I'm sorry, say u, not a v. My u's and my v's look really similar. Okay. The 2 from this. So these will cancel, and then this will cancel with this. There should be a dx here. Or not there, here. So this part of the expression ends up just being x ln x dx. So this is like, to an extent, this is like an identity. We kind of know what this is. We know this integral. If you've done integration by parts, you will have seen this integral. So let's just go ahead and solve with another form of integration by parts. So I'm just going to do this next part in a different color. So our u has to be log x, and our du has to be 1 over x. This I just know. You could also use LIAT, but I just know that when you're doing this specific integral that this is how it sets up. Okay. So uv times v du. Once again, dx up here. So these will cancel, so we're just going to get x over 2. And then integral of x over 2. So it's like what times what gives you that. Well, you could do, so you could just say, oh, I have x squared times, what value in terms of in front of x will give me 1/2. Your answer is 1/4. Or you could rewrite this integral in terms of and move the 1/2 out to the front and just do x. There should be a x here. And then your answer here is obviously 1/2 x squared, and then you have to multiply this entire thing times 1/2, and you're gonna get 1/4. So that's two different ways that you could solve that integral. For me, this is how I would have solved it. But the other way is just as easy. It just takes a little bit more knowledge of how the integral works, which considering this is a pretty basic integral, you should have that knowledge. So keep in mind this whole thing is from 1 to e, so that's what we're gonna have to remember. Okay, so x squared ln x over 2 over 2 minus 1 over 4 x squared. This is the integral of this part, so we're gonna minus x squared ln x squared over 2. So I kind of sucked at keeping it organized. So this up here was the integral of was the first what is it? The first part of integration, the first integration by parts that we did. This was our answer. Well, this technically. And then this when we took this integral, we got it down to this right here. Basically just this up here. So we're gonna have to minus them. There should be parentheses here, just to signify that minus is going everywhere to all the terms in the formula there. So I'm just gonna rewrite this entire thing in a different color. And then since this is the integral of our original problem, we're just gonna carry down our 1 to e. Okay, so now we're just gonna plug straight in. Okay, so I'm just gonna solve this like term by term. So ln of e is just 1, and then 1 squared times e squared is just e squared. So this is equal to e squared over 2. And then actually I did a subtraction error here. This should be plus because this negative applies to everything. This is why I added the parentheses. This negative applies to everything in here. So this was positive initially, like when this came out of the integral, this was positive. But since we have to minus this part, this integral, because of the formula, this negative times a negative makes this positive. Okay, so so we got e squared equals 2 for that, or e squared over 2 equals that. So now we're going to do e squared times ln of e over 2. Once again, this is going to be minus over here. Once again, ln of e equals 1, so we're just with e squared over 2. And then x squared over 4. Or e squared over 4, my bad. So there's nothing here that's going to there's no ln that's going to make it 1, so this is just our answer. So for this part at least, so we end up with, if we plug back in these values into the signs up here that they each had, we're going to be left with e squared over 2 minus e squared over 2 plus e squared over 4. So these will cancel, and this is our answer for this side of the boundary. So next we're going to just plug in 1. I'm just gonna do it up here because it's pretty easy. So one squared is just 1, so I'm not even going to write that. So ln of 1 squared over 2. Ln of 1 is just 0, because, you know, any e to the x equals 1, x equals 0. Minus, once again, ln of 1 over 2. This is just equal to 0. And then once again, 1, you plug in 1 for x, and you get 1 over 4. So our final answer is e squared. Our final answer is just going to be e squared minus 1 over 4. E squared over 4 minus 1 over 4. Because you should be able to, this is our answer for this side of the equation, and then our e squared over 2 was the answer, or e squared over 4 was the answer for this side of the equation. And since it's fundamental theorem of calculus, I think it's the second part, I could be wrong. It says e squared over 4 minus 1/4, because you know you do this part of it minus this part of it. So this is your final answer. Let me write this in a different color. This is it right here. You could also simplify this since they both have the same denominator. You could do e squared minus 1 over 4. So yeah, that's how you do this. That's how you do this integral. This integral up here. Yep. So this integral is really not that tough. It's just a lot of integration by parts. But it's not really implying any like crazy tricks that really, you know, are really hard to see, and it's not requiring that much rewriting. In fact, it really doesn't require any at all, outside of, you know, rewriting logx as ln x. And then down here, when you do integral of x over 2, you can rewrite that integral if you wanted to. So yeah, thanks for watching.